As you are about to get into your car one morning, you could find that it is covered in dust. It's quite likely that this sand has come from the Sahara Desert, even if it's hundreds of kilometers away. Sand particles in the Sahara Desert are disturbed by strong winds and drawn up into the atmosphere. Enormous plumes of dust particles are carried by the winds and often cover large areas of southern Europe. This almost invisible enemy can cause serious problems with energy production in solar power plants like this one in Toulon in southern France. Indeed, it reduces the amount of radiation towards the solar mirrors, which transforms sunlight into energy. The European MACC-II project, monitoring atmospheric composition and climate, informs plant managers of the frequency at which a certain location is affected by these large dust plumes, and by providing in the near future 5-day forecasts on a daily basis of the dust impact on solar radiation. For example, if a sun dust storm is foreseen, the complex operations to set the power plant in motion will be cancelled. What we see on the mirrors are dust and aerosols from the desert. Those are harmful to our facilities because they reduce the incoming solar energy, impacting on our system. If we know a few days in advance that a dust storm is coming, we will store surplus energy so that it can be used on the days where there isn't sufficient solar energy to operate the installation. This storage works at the moment with pressurized water. So there are kinds of big cans that will store water at very high pressure and very high temperature. When we want to discharge this energy, we will use the steam present in these containers to power systems of electricity production. But how is it possible to foresee the movements of desert dust? Here in the south of France, close to Nice, researchers of Transvalor, a private company specializing in research into solar energy, measure the quantity of the solar irradiation that reaches the ground. In this room, big screens follow the movements of the desert dust as seen by satellites. Then, by using mathematical models and algorithms provided in the framework of the MACC-II project, they predict the movements of the desert dust.
Aujourd'hui, les modèles météo
Today, weather forecasts have progressed greatly and are able to predict the desert sand that is raised and taken by the wind at high altitude to Europe, as seen here. These models are actually numerical models that run on very large computers, so they give us the transparency of the atmosphere, since the more sand there is, the less the atmosphere is transparent. And they also give us the forecast of what will become of the sand and how it will move in time in 3, 4, or 5 days. Solar energy is ever more becoming an important source of renewable power generation. Desert dust is a serious problem for the productivity of solar power plants. It obscures the sun and makes the mirrors dirty. Knowing in advance when a dust storm coming from the desert will occur is crucial to decide where to put future power plants and to better managing the existing ones.